So as you start this angle, I want you to take a minute to look at these triangles and kind of pay attention to the location of the short side and the long side, the short side, the medium side, the long side, and how it relates to the angles. If you look at question 1, what do you notice about the location of the shortest side relative to the smallest angle? So let's start by looking here. This is my smallest angle, and this is my shortest side. I can look at that, I can see that by the measurements that are labeled. In this next picture, my smallest angle is this 36.9 degree angle, and my shortest side is this side that is 3, GO, which has a length of 3. And then in triangle ABC, my smallest angle is 24, and my shortest side is this side length of 6 centimeters. Now what I notice is that every time my small angle is opposite from that shortest side. Okay, so the short angle, or excuse me, this is a short length, the short side is always opposite or across from the smallest angle. Notice that the sides that form angle C are not this third side, that's the short side. So here's the sides that form that angle, and that's not included. That short side's not included. Here are the sides that form the angle that's 40 degrees. The third side is the side that's not included. Now, what do you notice about the location of the longest side relative to the largest angle? So what I notice here is that I have two angles that are the same size, and I notice that I have two sides that are the same size. That's going to come into play later on when we talk about isosceles triangles. So in DOG, this triangle DOG, my largest angle is my 90-degree angle, and my longest side by measure is this 5 length, the length of 5. And then in ABC, my largest angle is this obtuse angle, 97, and the longest side is 15 centimeters. And it's no accident that the same thing happens, that the longest side is opposite the largest angle. If you were to take two boards and set a small angle between the two boards, the distance from here to here is much shorter than if I took two boards and put a bigger angle here in the middle. You have a much longer distance from board to board. So this angle here is relative to that side length too. Okay, so that makes sense when you think about it. So let's use that, order the angles of the triangle from smallest to largest. So we're going to, in order to order the angles, we need to look at the sides. So I want the smallest side first, so I need to, or the smallest angle first, so I need to look for the smallest side. So the smallest side is 9, which means that my smallest angle must be Q. My medium size length would be 14, which means that my next angle is S. And then my longest side is QS, this 15 length, and the side that's opposite of that is R. Okay, notice it's the side that is not a part of making that angle. Angle R is right here, formed by these two sides, and QS is the third side that's kind of left out. Now, what if we don't have a triangle? If you don't have a triangle, then you need to draw one. Of course, you can look at it, but it does get a little more complicated trying to pick out which angle's not included. So it's just easier, just draw one. It doesn't matter which letter goes where, then just label it. XW is 8, YW is 10, and YX is 15. See, this is much easier to look at because now I can see that my smallest side is 8, which means that my smallest angle is angle Y. Then my medium length is 10, which means my medium angle is X. And then my longest side is 15, and it is opposite of my biggest angle, which is angle W. So when we want to put the angles in order, we need to compare the side lengths. When we want to put the sides in order, we need to look at the angle lengths, or the angle measures. And so if I look at this angle measure, I need them from shortest to longest. So to start, I need the smallest angle. The smallest angle is this 30-degree angle. It's formed by these two sides. So the shortest side is going to be the side that's not involved in making that angle, which is WV. So that's my shortest side. My next shortest side will be this V, this angle V. Actually, that's not the shortest side, that's the smallest angle, but it will determine the medium-sized side. So here's my 70-degree angle. So here is my side that is not included in that, WX. And then I have my longest side and my longest angle, my largest angle. So 80 degrees, W is my largest angle, so VX or XV, either one, is my longest side. Now, what happens when you have only two angles? Well, you have to know all three of them. So again, I don't have a triangle. I'm going to draw one. I'm just going to label it. It doesn't really matter what it looks like. This is just for me to be able to keep everything straight. So I have angle D is 32. I have angle E is 74. So I do need to find out how big angle F is so that I can include it in the process. And so it is also 74. And so what we need to kind of remember about that is that triangle that we had back at the beginning. When the two angles were the same, we had two side lengths that were the same. So if I want to go shortest to longest, then my smallest angle is 32, which means that FE, my smallest angle is at D, so FE is my shortest length of sides. Okay, then the problem is I have two side lengths or two angle measures that are the same, which means that the sides that are across from them are the same. And so there are actually two side lengths, so then FD and ED are both the same length. And so they together are the longest sides because they're tied, because there are two angle measurements that are the same. Okay, so using that same idea, now let's take these triangles that are back to back, and see which side. Now, one of the things you need to realize is, just kind of take a step back. I can have a 30-degree angle right here, and this 30-degree angle has this side across from it. But if I were to take that same angle, so say this is 30 degrees also, it is very obvious because of the size of the triangle and the length of these other two sides that obviously this side is shorter than this side. And so we have to keep in mind that the lengths of the other sides do have an impact on how the actual length of that third side. But we just are looking at the triangles when they're drawn and comparing which one is longer and which one is shorter. So I'll show you why I showed you that. Let's look at this. So I want to determine the shortest side in the figure, okay? And so the shortest side in the figure, the way that you do that is you need to start with the smallest angle in the picture, okay? So we need to start with the smallest angle, which we don't have all the angles. And so since we don't have them all, we need to find them all. So these mean that they're the same length. Those markings mean that those two are the same length. We know that if sides are the same length, that the angles that are with them are going to be the same length. So if I take the 180 degrees and subtract 58, I have 122 degrees left, which means that each one of these angles is 61 degrees. Okay, so each one of those is 61 degrees. Then I know that I need this angle BAC, so 60 plus 61, and subtract that from 180, says that this angle right here is 59. So we start with it. So first, we have to find all of the angles if we don't have them. Once we have all of the angles, I can start with the smallest angle in the whole picture. The smallest angle in the whole picture is this 58-degree angle. So based on this triangle right here, based on just this triangle right here, I know then that AC is the smallest of the red triangle. Okay, so AC is the shortest length of that triangle. But in order for AC to be the shortest length of all the triangles, of both triangles, it also has to be the shortest of this other triangle. I'll color it yellow so you can see it. So we look, is that blue side the shortest length of the yellow triangle? It's not. Why? Because this 60 degrees is in the middle. So AC is the shortest of triangle ADC. But AC is the middle length. It's the mid-length of triangle ABC. So it is not the shortest in all of the picture. So then you have to keep going. So I went from 58 to that length. I start with my shortest one, and then I have to work my way around. So it's not the shortest length of the yellow triangle. Actually, BC is shorter because 59 is smaller than 60. And so actually in this entire picture, BC is the shortest side. It doesn't matter what it's drawn like. I know that it looks funny. It doesn't matter what it's drawn like. But based on the angles that we have, that 59-degree angle there has the shortest side that's across from it in BC. That's why I showed you these two triangles at the beginning, because I wanted you to see that I could have, even if I had, say, what if I had this really big obtuse angle right here? This side length that's here in yellow is shorter than this other red side length, even though maybe this is a 150-degree angle. So the angle itself doesn't necessarily determine, in different triangles, it doesn't determine side length, but within one triangle, you can compare them as long as they belong to the same triangle. So you start with the smallest angle. After you find all of them, start with the smallest one and then work your way through until you come to an agreement. If this angle, the 60-degree angle, had been the 59-degree angle, then I would have said, yes, AC is the smallest if those two angles had been switched. So once it's agreed upon between all the triangles, then you would stop there and you would say that. But in this particular case, because AC is the shortest side of the red triangle, but BC is the shortest